Now what we're going to do is humidify and take out a long-term wrinkle or kink in this sheet, in this book page. There's your moisture barrier. Put this on top first. So we want to just humidify this part. The rest of the sheet doesn't have to get wet, but with blotter paper or any other material, water is introduced into cellulose material and it's going to spread. With Zorbix, because of the superabsorbent quality of the internal absorption material, water only goes where it's placed and won't spread unless it's inundated with too much water. So you can control the amount of moisture that goes into the Zorbix and making it, like I said, a spot. So in the instance of humidifying a spot such as this line, if you want to be exact, you can go to the gutter of the book. Usually the increments of the metric scale are a little more accurate. Not accurate, just easier to read. So I'm going to make that at 11.5. And up here, we're going to go to 6.5. And I'm using water, so I'm not really marking the Zorbix sheet. And 6.5 at the top of the text block. Let's get it back in place. Nope. I'm going to use this as a moisture barrier and do a specific area that is humidified in a straight line. Paintbrush will work. Ruling pen works nicely. As you can see, it dropped all that water into the Zorbix. You'll also be able to see that the Zorbix absorbs the water, and you can watch it here begin to disappear, because once it's absorbed into the chemistry inside, the surface of the paper will be dry and there will be no chance of moisture transferring to the book. There'll only be humidity being transferred. Because I had refilled my pen here and here, there's a little bit more moisture there. You can see it cockling a little. You notice that line is now almost completely gone. And if we check, you can see that the Zorbix fold's there, and it's pretty much right on top, and I can move it directly on top. And I can put the moisture barrier underneath so that the sheet underneath doesn't have a chance to get damp. Water moves in well, we call it osmosis. It'll move to the driest spots. So the moisture that is now trapped in the chemistry will humidify everything around it. The bottom of this metal plate will have a little bit of moisture in that line, and the paper itself will become greater, have higher humidity. The humidity needs to raise up enough in the paper that, in this instance, to make that fold relax, that crease relax enough that we can then pull the sheet out, flatten it, and any humidity that is there we can then pull back out with a sheet of Zorbix that doesn't have moisture in it. I think I've been talking for about a minute. I'm going to do it again because the crease, as you see, is a double crease. So this time I'm going to use a brush. I already know approximately where I want to put the moisture, but I want a wider swath of water. I don't have to use a ruler, but in this instance, because the crease is relatively straight, now you see that I'm putting a lot more moisture in than I did before, and I'm to the outside of the book from where the line is, because when the sheet got unfolded, it moved outward. I'm going to set it aside. If for any reason you don't want your metal to touch directly, you could put a waste sheet on top. Once you get into the practice of using Zorbix, you'll be able to tell just how long it takes to humidify something. It doesn't take a lot of humidity, and one of the advantages of Zorbix is that you don't inundate the Zorbix with water, which then makes the full sheet wet. You're only humidifying the area that the moisture is inside the Zorbix. And the whole sheet of paper doesn't then relax, and then you don't have to dry it under pressure so it doesn't cockle. One of the ways you can tell that, you can see that there's no, let's call it wetness here. You can see the cockling, but there's no, let's call it dampness. And when you humidify something, if it's cold to the touch, you know that it's beginning to relax. This crease right here is still fairly strong, pronounced, because the cellulose here, the paper fiber, hasn't had enough moisture. I'm going to humidify it again. Although there is still moisture in here, and you can see that with the light right there, you can see that there's liquid in there. But that liquid is, again, it's trapped in the chemistry. It's not on the surface. The surface, in raking light, you can see that surface is dry. I don't think I have to rehumidify it. I think I just need to reposition it and leave it a little bit longer. One of the advantages of Zorbix is that you can add as much humidity as you like, and you can take it out relatively quickly. Because it was designed as a super absorbent for drying wet books, the pulling power of Zorbix is 50 times its weight in water. That means if you have an ounce of water, 50 milliliters of water, you can pull that 50 milliliters out 25 times as fast as if you had a blotter paper, which could soak up 2 times its weight in water. So it's a bit like a car with a very large engine rather than a very small engine. You can speed the process of drying because the superabsorbent will soak up so much more water than blotter paper will. This is flattening out and relaxing. This still needs a little more time. And this time I think I'm going to add another bit of water to it. So if you note, here it's, let's say, a little bit off-white or gray. Wherever the water is still on the surface, it hasn't absorbed into the superabsorbent yet. So it's still liquid at this point. It's been sitting there for a little over a minute, so we're going to give it a try. I don't know if it shows on the camera, but that crease is a lot flatter now. It's not raised up and high. The paper does not feel wet at all. Slightly cold to the touch. One more try, and this time I'm going to add weight to it. So the factors are how much you load the Zorbix up with water, how long you press it for. Additionally, how much pressure are you giving it? Pressure is the accelerator, because the greater contact with the moisture or the humidity that the paper has, the faster the humidity is going to travel to the dry spot, which is the crease. In this instance, what we want to relax. We'll go for 2 minutes. All right. You can still see the crease, but it's laying flat of its own now. In order to make it flatten out completely, pull out the moisture quickly with a sheet of Zorbix. In order to make this as flat as possible, it'd be ideal if I had a platen of, let's say, thin aluminum or something like that. But this is a smooth platen, and it's harder surface than the paper in the book itself. Take a sheet of Zorbix. You want to make a sandwich of Zorbix so that you're using the pulling power of the superabsorbent chemistry itself to drag the water back into this new sheet of Zorbix. We'll apply as much weight as we can to make this go relatively quickly. The sheet is dry. At this point, if I wanted to go farther, I could rehumidify this. Maybe get a metal plate, put it in here, and use some pressure again. But rehumidify this, and that would work out that crease. There is a bit of dirt here that's going to stay because the dirt is in the paper. If you wanted to wash the paper, you could get rid of the staining. That's a relatively quick demonstration of how to relax paper with Zorbix. This book The Annals of the West, Principal Events, Cincinnati, 1847. Fairly good shape for its age.